Okay, let's talk about our final mutation type. Ready? The final mutation type is frame shift mutations. Now, in order for frame shift mutations to make sense, we must first understand a concept called the reading frame. Now, we actually already understand the concept of the reading frame. In the reading frame, when we look at a transcript, an mRNA, and we look at the nucleotides in that mRNA, we do not look at the mass of these nucleotides. We look at them in sets of 3 as codons. The reading frame is sets of 3. In other words, reading frame is codons. So what happens in a frame shift mutation? We get a deletion or an insertion mutation that alters the reading frame. So first off, an insertion mutation is when bits of chromosome get inserted into the wrong spot. And deletion is where you actually remove chromosomes. So for instance, if here's my chromosome here, and we have a deletion, we might have lost some DNA. So here's my deleted DNA. This is a deletion. So that is the site where my break in the DNA happened. And we ended up having some DNA cut loose, and this is our deleted DNA. So that's a deletion. An insertion would be if this bit of deleted DNA ends up getting added to our chromosome in a different spot, or even possibly to a new chromosome. So we have a break, and then our deleted DNA gets added in. So this is an insertion. So either a deletion or an insertion occurs, and it alters the reading frame. What does that look like? Well, let's just do one of these. So all it needs to do to alter the reading frame is basically delete one or two nucleotides, basically delete nucleotides that are not in a multiple of 3. So let's do a deletion because it's easy. And we'll delete these 2. And once that happens, once those 2 nucleotides are deleted, we have to redraw our codons. Right? Our entire set of codons has changed. So CCA, UGA, GAC, ACA, CUA, and we have like lost our stop. So this might mean that it starts to include like basically when this transcription occurs, once that stop codon is lost, it can alter how transcription occurs, and you might end up getting like this gene that's had reading a frame shift end up getting transcribed in combination with the next gene over, and you'll have some weird Franken gene because of the frame shift. So this reading frame shift ends up changing all the nucleotides after it. So it's extremely like you are definitely getting some kind of nonsense mutation because of that frame shift, right? So every codon after the mutation is altered. So this generally causes major change in the protein. You are almost guaranteed to have some kind of nonsense mutation, right? Once you have that frame shift and you've changed every amino acid from that mutation on, you're almost guaranteed some kind of nonsense mutation. Almost like it will not have its original function because you've changed all the amino acids. You'll be real lucky if there's any like codons that were silently mutated, but every single codon after is part of that frame shift mutation and is now going to have an alteration in what gets produced by it, right? Here, yeah, so you can see that everything changes. So frame shift mutations are a big deal because they change the reading frame. So if you get a number of nucleotides deleted out of that chromosome that are not in a multiple of 3, then the reading frame shifts. So it is possible to have a deletion mutation that is not a technically reading frame mutation. It just, if you do that, it just has to be a multiple of 3, right? So if you lose, right, if you lose 6 of these, your reading frame your reading frame isn't changed. You lost 6 amino acids, but your reading frame remains the same. It's bad. It's just not technically a reading frame mutation. Is your professor likely to try and gotcha this with you? I'm not gonna like ever have a student be like, hey, if there's a deletion of 6 nucleotides, is it a reading frame mutation? That feels like a dick move to try and get a student to like trick question on deletions that aren't reading frame mutations. In the context of transcription translation, if I start talking about insertions and deletions, you can bet I'm talking about reading frame mutations. But this brings us to the very end of our Biology Bites on translation. Woo-hoo-hoo-hoo! Everybody, take a nap. So, enjoy yourselves. 'Tis the end. You know, whatever.